Greetings and welcome to Physical Science at Hack. In this video, we'll work through a few examples of the problems from Chapter 3 on energy in our textbook. So I'll go through a few examples here, and you'll see some similar problems in the homework set that you'll be working on as well. So good example here to kind of review how to do some of these problems. So let's start off looking at the first one, which says that a force of 200 newtons is needed to push a table across a level classroom for a distance of 3 meters. How much work was done on the table? Well, as usual, let's write what we know first. Let's say that we know that the force is 200 newtons. So that's the force. And the distance is equal to 3 meters. So how much energy is done? Well, how much work is done? Work is equal to the force times the distance, and in this case we're pushing it across a level floor, so we're pushing the force in the same direction at which it's moving. So there will be work done, and that's equal to the force times the distance, or in this case 200 newtons times 3 meters, which is equal to 600 Newton meters, which is the same as 600. A Newton meter is a joule, so that's 600 joules. So our answer is then 600 joules, and there we have the answer for the first problem. Now the second one asks about the kinetic energy of a car, so let's scroll down a little here and look at this. What is the kinetic energy of a 2,000 kilogram car moving at 72 kilometers per hour? Again, write down what we know. That's always a good starting point. The mass is 2,000 kilograms, and the velocity is 72 kilometers per hour. Now, the problem here is that the velocity is not in the correct units. So we have to convert that. We have to take the velocity that we have, 72 kilometers per hour, and we have to convert that to meters per second. So we have to multiply that by 1 hour, which has 3,600 seconds, and times the 1,000 meters in a kilometer, which means that our velocity is 20 meters per second. So we have to do that first in order to be able to do the rest of the problem. We have to convert it to the right set of units. So now we can go through and use our equation for kinetic energy. Kinetic energy equals 1/2 mv squared. So that is equal to 1/2 times the mass, which was 2,000 kilograms, times the velocity, which we just figured out over here, of 20 meters per second squared. Okay, let's go ahead and simplify this. This is equal to 1/2 of 2,000 is going to be 1,000 kilograms. If we square 20, we get 400. Now our units have to square too, meters squared per second squared. So that is now equal to 400,000 kilograms meters squared per second squared. Well, what is that equal to? Let's look at what our units are. If we have kilograms meters squared per second squared, that is a kilogram meter per second squared. That's a Newton times a meter, which means that our answer is 400,000 joules. So double checking the units there is never a bad thing to do to make sure you haven't done anything silly like multiply when you should have divided. So that would be 400,000 joules for our answer for the second problem. Now let's go look at our third problem here, and let's see what we can get. Our third problem says how much work is done in moving a 2.0 kilogram book to a shelf 2.00 meters high. So first we have to find out the amount of work done. So let's again write down what we know. We know the mass is 2.0 kilograms. We know that the distance it's moved is 2.00 meters. So now we need to find the amount of work done. Well, we know the work is equal to the force times the distance, as we've done before, which equals, so this is part A here, which is equal to the force. How do we get the force? Well, the force when we're lifting something is just the weight. So that's mg times d. So that's equal to 2.0 kilograms times, we didn't write down, but we do know since we're lifting something that g is 9.8 meters per second squared. So let's put that in there, times 9.8 meters per second squared, times the distance, which is 2.00 meters. Now, if we multiply all those out, we find that that's equal to 39 kilogram meters squared per second squared, which, as we learned in the last one, we know that that is 39 joules of energy. So that would be the amount of energy needed to lift, how much that would be the amount of work done in lifting this book up 2 meters to the top of a shelf. Now, what we want to look at, let's look at part B here. Part B says, what is the change of potential energy in the book? Well, the change of potential energy is going to be equal to exactly what we did. Potential energy is equal to mgh. But we've already done that. That's exactly what we figured out. The amount of work that is done in raising an object is going to be the same as the ending potential energy. So it's mgh, we know, or we've already calculated that. I won't go through the calculation again. We know that that is 39 joules. So part B is also 39 joules. So very easy one there. You can just explain how you got that, and you're fine. For the last one, part C here, how much kinetic energy will the book have as it hits the ground when it falls? Well, again, kinetic energy equals what? 1/2 mv squared. We just did that in the previous problem, but we don't know the velocity. We don't know any of that yet, but we do know the conservation of energy. The kinetic energy when it falls just before it hits the ground is equal to the potential energy that it had when it was on the shelf. So we know that those two are equal, and therefore it's 39 joules again. So what would have looked like, might have looked like a much longer problem, ended up being relatively simple because you could summarize a couple of the pieces together. Now, our fourth question for this assignment asks about the kinetic energy of a 1,000 kilogram car that is traveling at 90 kilometers per hour. So, once again, we have to write down what we know here, and we know that the mass of the car is 1,000 kilograms. We know that the velocity of the car is 90.0 kilometers per hour. Now, just as we did before, we're going to have to convert that velocity. So, I'm going to run down here, 90.0 kilometers per hour. Multiply that by the fact that 1 hour has 3,600 seconds, and multiply it by the fact that there are 1,000 meters in a kilometer, and we find that the velocity is then 25 meters per second. So velocity is going to be 25 meters per second. So the 90 kilometers per hour is the equivalent of 25 meters per second. That's what we'll need for our problem. So we know that the kinetic energy equals 1/2 mv squared, and we know all our numbers now, so that's equal to 1/2 times 1,000 kilograms times the velocity, which we've converted, 25 meters per second squared. or it's equal to 500 kilograms times, we square the 25 and get 625 meters squared per second squared. And if we put all that together, we're going to find that that is 313,000 joules. Sometimes we write that as 313 kilojoules, just to simplify the numbers, remember, using the metric prefixes. So that would be our answer, would be 313 kilojoules, or equally valid would be 313,000 joules. Both of those are exactly the same. Now that was part A. Here, part B asks how much work was done to give the car this kinetic energy. Well, how much work? What do we know for work? Work is equal to the force times the distance. Well, we don't know about distances that were traveled or forces or anything else. So what can we do here? Well, we know that this work done has to be equal to the kinetic energy that it's given. The amount of work that was done has to be equal to the total kinetic energy that it was given, which is, as we know, 313 kilojoules, because we already figured that out. So again, like the previous problem, it's a relatively quick one here if we just remember that we don't have to try to figure out the forces and the distances, because we don't know any of that, but we do know the amount of energy. How much work must be done to stop the car? That's the last part, part C. Well, the work to stop the car will be exactly the same as the work to start the car. To get the car accelerated up there, it has a certain amount of energy. In order to stop it, we have to lose all that energy, so it would also be 313 kilojoules. So if you have problems like that on the homework, there's not a calculation required, and although I didn't write it down here, the only thing you would have to do is write down your explanation so that I can see your understanding of the topic. So I didn't bother to write all of that here because I'm explaining it as I go. If you're turning it on a homework, then you would need to do that. Now we have one more problem here to look at, which asks for the velocity of a car. What is the velocity of a 1,000 kilogram car if its kinetic energy is 200 kilojoules? So what do we know now? We know the kinetic energy is 200 kilojoules, and we'll also write that as 200,000 joules because we'll need it converted into that set of units. And we know that the mass of the car is 1,000.0 kilograms. So we know the mass, we know the kinetic energy, we can now find the velocity. How can we do that? Well, kinetic energy equals 1/2 mv squared. Now we have to solve for v. So v is equal to 2 times the kinetic energy divided by the mass. And we have to take the square root of that entire thing. So now we know all the numbers on this side. We know the kinetic energy, we know the mass, and so we can figure that out. So that is the square root of 2 times 200,000 joules divided by 1,000 kilograms. And if we work all that out, what do we find? Well, let's first of all multiply the top. We're going to find out that that is 400,000. So that's the square root of 400,000 joules divided by 1,000 kilograms, which is the square root of, if we divide 1,000 by, or 400,000 by 1,000, we get, what, 400 joules per kilogram. Well, let's take an aside here and look at our units. A joule is a Newton meter, which is a kilogram meter per second squared times meter. So if we take that in here, we would have that our answer is 400. And let's look at our units. And again, it's always important to do that. It's 400 kilogram meters squared per second squared divided by kilograms. So the kilograms are going to cancel. there. And we're going to get 400 meters squared per second squared, and we just have to take the square root of that, and that ends up being 20 meters per second for our velocity, and is our final answer for the velocity of this car. If we know its kinetic energy and its mass, we can then figure out what its velocity is. So that concludes our problem examples for Chapter 3. And we will continue on next time and go through some examples for Chapter 4. So until then, have a great day, everyone, and I will see you in class.